looking at a picture of pumpkins like this, you can see some of them look more perfect than others. It's an agricultural commodity. It grows on a vine. They don't grow underneath the dirt like potatoes or anything. They grow on top of the dirt, right? So they're subject to the weather, pests, and obviously for the FayettevilleFlyer.com, they picked out the best pumpkins they had, right? These are some pretty nice looking pumpkins. But even still, I can see from up front, there's a little scratch on this big one. 2 or 3 scratches. And if you've been out to a pumpkin patch before, you've seen those that just get left behind. They're just moldy and nasty. If they're a perfect one, those ones go pretty quick, right? Families get out there, especially early in the season, and like this is like prime time to go get the perfect pumpkin because, you know, we've got 2 more weeks before Halloween. Good luck. It's like getting a Christmas tree on Christmas Eve, right? You kind of get the Charlie Brown Christmas trees if you do that. So anyways, you can just think through, and actually some people might like, anyone like these ones on the bottom left? I started acquiring a taste for them lately. They look different, and they look kind of artsy, but they don't look like your beautiful, just all orange pumpkins. So it kind of depends on the eye of the beholder. What's a perfect pumpkin? But you can think for yourself, are you going to decide that this orange one on the bottom left with all the orange, looks like warts, doesn't it? And same thing with this dark one right here. Is that defective or is it not? And as a class, if we just said, yeah, we're targeting a perfectly round orange pumpkin with no scratches, no mold, no warts, that could be our definition of the perfect pumpkin. And then from there, we can think about all of the attributes that might be defective. And we can go from there and think through, if you were a pumpkin farmer, what type of a control chart would make most sense for you? And as a reminder, we can draw a line right here, because for the top 2, we're interested in how many out of all of these are defective. We don't care what makes them defective. It doesn't matter if they have a scratch or if they're moldy or if they have a wart. That's all we care about. We just want to know how many are going to get left behind or something like that. Whereas if we are concerned about the C, the count of nonconforming units, or U, which is basically the same thing. We're just going to use U for when the sample size varies. Then we're going to be, on a pumpkin like this, counting how many nonconforming units there are. So for this one, I would count 1, 2, 3, just based on the naked eye on this Google picture right here. So right there, our C would be 3. Good luck counting all the warts on this one. I don't know how you would do that. The count of that, if you said a wart was a nonconforming unit, would probably be 200 or something like that. So it's kind of a weird example for that case. But let's say, hypothetically, how many pumpkins would you guess are in this picture here? 1, 2, 3, 4, 5. I don't know, about 25 or something like that if we had, oops. If we had 25 pumpkins, and let's say the defective, let's just guess that we have 5 that are defective, then our P is simply going to be 5 divided by 25, which is 5 times 4, 0.2. Is that right? Yeah. 0.2. Our proportion nonconforming 5 times 4 is 20 divided by 100. Yeah, that's right. So we have 20%. That's our proportion non-conforming. Does this make sense?